Number 40. A world record was set for the men's 100-meter dash in the 2008 Olympic Games in Beijing by Usain Bolt of Jamaica. Bolt coasted across the finish line with a time of 9.69 seconds. If we assume that Bolt accelerated for 3 seconds to reach his maximum speed and maintained that speed for the rest of the race, calculate his maximum speed and his acceleration. Okay. So this is a difficult problem. So let's draw a picture. I think a picture we'll be able to simplify this. So here we have Bolt, and he is going to be running in this 100-meter race. So it says initially, right, he's going to be accelerating. Okay, with some value we don't know, but his acceleration will equal something here. Okay. We know he's starting from rest at this point, so VI is 0. Remember the whole race is about 100 meters long, so let's just say it's going to be something like that. So this will be the 100 meters. Okay. And what else does it tell us? And Bolt accelerated, it told us though, he accelerated for 3 seconds. Okay, so the time, we know the time here would be 3 seconds. All right. And at that particular point, he reached his maximum speed. So at this location right here, we'll consider this like his final velocity, okay, of the first part or this frame in black. Okay. And we don't know what that final velocity is. But then they said that moving on forward, right, he's going to maintain this final velocity or this maximum velocity now for the rest of the problem until he finally reaches the finish line. Okay, so if I think about now, what does it look like? What does this frame of the problem look like? We already know the time, right? For this particular frame in gold, it would be the total time of 9.69 seconds minus the 3 from the first part, right? So that should make sense. So let's do that in the calculator. So 9.69 minus 3. And why do you need a calculator for that? I don't know. But just to be safe, 6.69, that'll be in seconds. Okay, great. What else do we know about this? Well, we also know that the velocity value here, so think if I'm considering this my this frame, the gold frame, right? This really is my initial velocity because that's the start of my gold frame, okay? And then this would be considered the final velocity. But remember that we don't know either of these, but they're both going to be the same, right? Because there's no acceleration in this part. And the final velocity of the first part is equal to then the initial velocity of the second. Okay, so that's cool. And what else could we do here? Well, we could also talk about the displacements, one other thing, right? So let's dot a line down here. Now what I can think about is I can consider now this distance here, okay? I'm going to call it x1, right? Because I really don't know what it is. But I do know that if I call the left-hand side x1 and I call this side x2, well, they should both add up to 100, right? So that'll essentially be my first formula, okay? My first formula here is going to be that x1 plus x2 equals 100. Okay, so now from here, what I'm going to do is I'm just going to start. I mean, it might be hard to plan this out, all right? And it might be difficult to try to see where to go, and no big deal. Just start picking some formulas and start writing some stuff in, okay? If you're lost, don't worry about it. Just try to push forward. So on the right-hand side, let's take a look at some of these formulas, and let's just write in some stuff. Let's start writing stuff down. Okay, so let's first talk about the frame in black. All right, so for the frame in black, I could write a formula of VF is equal to VI plus AT. Now, for the frame in black, do we know the final velocity? No, we don't, so just leave it as the final velocity. Do we know the initial velocity of the frame in black? Yes, we do. It's 0, right? So that essentially drops out. Do we know the acceleration of the frame in black? No, so just leave it. Do we know the time? Yes. So that's a 3. All right. So let's clean this up a little bit. So we know the final velocity should be essentially 3 times the acceleration. Okay, now that's fine, but that's not an answer. All right, that's just a simplified equation. So now maybe can we do some other things, or maybe is there anything else another equation we might be able to use to describe the part 1 scenario here? Well, maybe. So I already used the top one. Okay, maybe why don't we use, and let me change these a little bit. Let me use the second one now, all right, to describe the frame in black. And why am I doing this? Why am I choosing these two? Well, part of it could be a little random. I'm just seeing what works. But also I know that the initial velocity is 0. So when I choose these formulas, I know I can get rid of a term. So it helps simplify things. So now let's take a look. So the displacement of now this is important. You got to think about your frames, okay? So the displacement of the first frame should equal the initial velocity of the first frame times the time of the first frame, plus 1/2 times the acceleration of the first frame times the time again of the first frame squared. Okay, so we got all these ones. So the displacement of the first frame is just as I called it, x1. Okay, so that just is x1. Now, what's the initial velocity in the first frame? 0, so this whole term goes bye-bye. And now that's equal to 1/2. The acceleration in the first frame, do we know it? No, so that's fine, so just leave it as a. Okay, and then the time of the first frame, do we know that? Yeah, we do, they told us, right? 3 seconds. So it's 3 squared. Okay, clean it up a little bit, do the math. And 3 times 3 is 9, times 1/2 is 4.5, right? So x1 equals 4.5 a. Okay, interesting so far. So now you might say, well, wait, can I solve anything here? Can I do something with these two? Well, not really, right? The problem is we have 3 unknowns. We have a, x1, and vf, but only 2 equations. So we can't do anything yet. All right, no big deal. Well, you might say, well, wait a minute, I know this third equation over here. Can I plug this in and do something? No, same thing. We're going to just substitute the x1 for the x2 now in this problem. So no. Okay, so don't worry. So we can't do anything here yet. So maybe now we have to jump to the gold frame. All right, maybe we got to start writing some stuff down over there. Maybe we got to start thinking about formulas that may include the x2. And let's see if we can, right? So let's see. Maybe, well, let me think about this one. Maybe I'll use this same equation again. Let me use this equation to now describe the gold frame. Okay, so let's write it carefully. The change in displacement of the second frame will be equal to the initial velocity of the second frame, right, times the time of the second frame, plus 1/2 times the acceleration of the second frame times the time of the second frame, squared. Okay, so what's the displacement of the second frame? Well, I just said it's x2. All right, so just leave that x2. What's the initial velocity of the second frame? Well, here's the key. Here's the initial velocity. I said we don't know it, but remember, before I said that the initial velocity of the gold frame, or the second frame, is going to be the same as the initial velocity, as the final velocity of the black frame. So what I'm actually going to do here, instead of writing the initial velocity of the second frame, I'm going to write the final velocity, okay, of the first frame. Okay, that's then multiplied by the time of the second frame. Do we know that? Yeah, we do, 6.69. And so that's 6.69. Plus then 1/2, right? Actually, let me not write it out yet. So let's think about it. 1/2, right, times the acceleration in the second frame. What is it? We know it. It's 0. So guess what happens? That whole term drops out. Again, why did I pick this formula? Because I realized that the acceleration is 0, so I can simplify it a little bit. All right, so let's clean this up now. So we got x2 is equal to the final velocity of the first frame. Actually, you know what? I'm going to reorganize it. 6.69 times the final velocity of the first frame. Now, do you have this variable any other place in your other equations? We do, right? I just didn't mark it as a little 1 down there, but remember, I did do this formula for the first frame, so I can put up my little 1 down there. Okay, and this is really A1 as well. Let me mark them all 1s. So what I can do here is maybe I can do a little substitution, right? maybe what I can do is maybe relate these two together or something like that, right? So let's see what happens when I plug one in for the other. All right, maybe what we'll do is why don't we take essentially this value, all right, since that's equal to VF1, let's take that and then plug it in to here. What do we get? So we're going to get, this is now, let me just write a different sign. So this is now x2 is equal to 6.69 times 3 times the acceleration of the first frame. Okay, does that help me at all? Well, maybe not. I don't know. I don't think so yet. I can't really simplify it. All right, let's try something else. Maybe what about this now? Well, I notice I have an A1 in here, right? And I notice I have an A1 here. So maybe what happens if I solve this thing for A1, right? And then plug that in. All right, so remember, to solve that for A1, you would just have to divide out the 4.5, right? So then that would mean that A1 is equal to x1 over 4.5. Okay, well, let's take this now and plug it in for here. All right, let's see what happens. So I'm going to take now, let me change the color. So we're going to take now, so this is going to be equivalent to x2 is equal to 6.69 times 3 times x1 over 4.5. Okay. All right. So look, it's getting a little crazy now, right? We got a lot of numbers. Let's just simplify it a little bit. We can do the math between these numbers, right? So let's try to clean it up. So we got x2 then is equal to 6.69 times 3 divided by 4.5. So it comes out to 4.46. 4.46 times x1. Okay, well, oh, man, we still didn't get it. What do we got to do? Well, wait a minute. Go back and look at what I drew in red. Now look at this. Interesting. Okay, what do I have here in the box where I start? I have an initial equation. And how many unknowns do I have in this equation? I have 2, both x1 and x2. Now notice, in the new equation I just created, how many unknowns do I have? I have 2, both x1 and x2. But guess what that means? Now we have 2 equations with only 2 unknowns. And this is wonderful because now I can actually solve for one of them. Okay? So let's do that. So let me just write them here at the top again. So x1 plus x2 is equal to 100. What I'll do here is I'll solve this thing for x2. So just subtract the x1. All right, so x2 now is equal to 100 minus x1. Okay, great. And let me rewrite the equation that I came up with at the bottom. All right, so we said x2 is equal to 4.46 x1. So now look what I can do. Since this term equals x2, right, since that equals x2, what I can do is just plug it in. And lo and behold, look at what happens. Now I have 100 minus x1 is equal to 4.46 x1. Hooray, right? Thank goodness. Now I have one equation with one unknown. This is amazing because now I can actually solve for x1. So I add one of the x1s on over. So we get 100 is equal to 4.46, excuse me, not 4.46, 5.46 x1. Now this thing looks kind of like a multiplication sign. I didn't mean for it to, but it has to be an addition sign, right? Because we're adding it. Okay, now just divide out the 5.46 x1. Not x1. Don't bring the x1 over, please. Divide out the 5.46. All right, and now we realize that x1 is equal to 100 divided by 5.46. So we get an answer of approximately 18.3. Okay, great. And we'll have 3 significant figures. So 18.3, and that number is in meters. Interesting. So where is x1 in the picture? This is x1. Okay. So here's x1. Now, I know that this distance, x1 here, is, the distance here is 18.3 meters. Wonderful. Okay, so can I now solve for the acceleration? Well, we can, right? We can, but we don't even need to. We don't even need to really go back that far. We don't even have to think about a new problem. All right, I got initial. I don't know the acceleration. I got time. I got this. How do we solve it? Look, we already created a nice equation here. Take a look at this. I'm going to box it in red. Bottom. Look at this equation I created. Right? What does that equation say? That equation says, and I'm going to write it over here on the right-hand side, that equation says that the displacement of the first part will be 4.5 times greater than the acceleration of the first part. So remember, it's asking us to calculate the acceleration in the problem of when the acceleration that he's obtaining for 3 seconds at the beginning of the race. So we do know x1, right? We just found it. So we'll just plug it in. So 18.3 is equal to 4.5 A1. How do you solve it? Divide out the 4.5. And let's see what we get. A1 is then equal to, let's give it a go. So we got, and I think I should have had, I probably should have had another sig fig here, I think. Because this was really the number here was 3.00. Okay, so this should have been 4.50. So we got 18.3 and then divide it by 4.5. And wow, cool. So the answer comes out to be 4.07 meters per second squared. This is an answer. That is our answer, right? So that works great. That's the answer that's the one answer to part A. Okay, so we did the acceleration. Now look back at the problem. We need to find the maximum speed. How do we do that? Well, look at some of the equations that you generated already. Right? Bottom left-hand side, take a look. We know this. Right? We found this equation before. What does this equation tell me? This says that the final velocity of the first frame, which is essentially the maximum velocity, right, he will obtain, will be 3 times greater than the acceleration of that first frame. So we just found the acceleration of the first frame, right? So upper left-hand corner. So the final velocity of the first frame, which is the same thing as the maximum velocity, will be 3 times the acceleration of that first frame. So the final velocity of that first frame is equal to 3 times the value we just found, 4.07. So let's calculate that. So 3 times 4.07. 22.1. So we got 20. Oh, no. What am I talking? 22. Look at it. I just have to open up my eyes. 12.2 meters per second. Okay, and remember that the final velocity of the first frame is equal to the maximum velocity, right? So we can say that Vmax now is equal to 12.2 meters per second. And that would now be the answer to part A. Now, I ran out of room, but let me walk you through part B. So during the same Olympics, Bolt also set the world record in the 200-meter dash with the time of 19.3 seconds. Using the same assumptions, meaning that he accelerated to his maximum speed in 3 seconds, right? What is his maximum speed for this race? So you would literally do the exact same thing, okay? So what do I mean? You would first set up the problem, draw a picture, challenge yourself here. Set up the picture just how I did here. Okay, set that up. And then you can do the exact same steps. Set up your distance equation. Okay, then set this equation up. Set this equation up. Set this one up. Then start plugging stuff in just like I did. All right? And you will arrive at your answer. I promise. I realize I left the box out there. All right? But I think, so in that particular problem, I believe he reached a maximum velocity of about 11.2. So check your work. You have the answer. All right, give it a go. All right, thank you guys for checking in, tuning in. I hope this helped, and I will speak to you soon.